Alright engineers, welcome to your last OnShape demo. So we're going to be finishing up assemblies, looking at two new mate connectors, and then you'll be able to use all your skills to make some really cool projects. So today we're going to be looking at two new mate connectors, which if you remember, these mate connectors allow us to give parts interactions, and we can make them have specific interactions so that they have realistic motion. So we can set limits on how far they can move, where they can touch, and those different types of things. And we do that all in this assembly panel here. So in order to do this, in order to make this catapult here, you can see that there are several different parts. So we have our base, we have the right panel, we've got the left panel, and we've got the arm. And so all of these together, when we put them together using the Fasten and the Cylindrical Mate connectors, we create this catapult that has realistic motion. Notice how when this is coming down, it's not running into this plastic here, it's not going through it, it's stopping right there. When it goes up, it's going to actually end up hitting. So these are going to be where our rubber bands are. We can't model rubber bands in OnShape, but we can imagine that if we had rubber bands here, this is where they would stop. And so that is going to be what we're creating. Let's go ahead and get started with this. In order to do that, the first thing you need to do is you need to make a copy of all the parts. Eventually, you will be creating all these parts on your own when you do your own catapult, but for today, we're just focusing on assemblies. So you'll click on the three bars at the top, and you'll copy that workspace. Make sure that you rename this correctly. Your class name underscore assembly demo 2 underscore your last name. Alright, so now that we've got our copy of our document with all of our different parts, first thing we're going to do is we're going to actually create that assembly tab so we can put all these different parts together. So to do that, we'll click on Insert Part, Create Assembly, and now we have this assembly tab. I'm just moving it to the end here, keep it a little bit more organized. Alright, so the next thing we'll do is we'll start to bring in our parts, and the first part we need to bring in is our base. So we'll click on the base, and we can set that wherever we want. Setting it around the origin is probably a good idea. It'll just be easier to zoom to. And then we'll just confirm this for a second, because the next thing we need to do is we need to fix this base in place. Okay, so today you're going to learn about the Fasten Mate connector that is different than fixing a part in place. When you fix a part in place, which you can do by right-clicking on the part in the menu and clicking on Fix, what that does, and this icon comes up, is that fixes the part so it does not move anywhere. You will not be able to move this, and then anything you connect to this will be fixed in that place as well, unless you allow it to have different degrees of freedom or motion with the Revolute, maybe the slider, or what we're going to learn today, the Cylindrical Mate connector. So again, fixing is different than fastening. The one part that needs to be fixed, and the only part that needs to be fixed, is that original base. And when you're coming up with any of your other projects, whatever the part that everything's being built around, that is the part that needs to be fixed. Okay, so now that we've got the base fixed, we can go ahead and bring in our first part that we're going to attach to that, and that will be the left panel. So we'll bring this in here. So you can see that we have these little kind of tabs here that are going to go into the base. So because we want these tabs to go in, and when we put these in here, we don't want them to move around. So it's not like we want these arms sliding in and out. Once we put these things in, the way that we made these dimensions, they should barely fit. I mean, they should be really snug together. And if we wanted to, we could even put some super glue in there to make sure that they don't move around. But to show that in OnShape, that's where we're going to use the Fasten Mate connector. So the Fasten Mate connector is like super glue. When you click these two different surfaces together, they will be connected like super glue. So we'll choose the Fasten Mate connector, and then we can choose either of our two tabs. So the surface on either of these, we can choose this one or this one here. The only thing that matters is that if we choose, the back one, then we need to choose the back of the inside of the base. If we choose the front, then we need to choose the front. So I'm just going to choose the back. It's going to be a little bit easier to get to for me. So first thing I'll do is make sure that I'm on the surface of my tab there. And then I'll rotate around, and I'll zoom in to get to the surface of my base. And I can zoom to check. and that looks great. So if we click here, this is going to bring up another Fasten Mate connector, and some people thought that that was like an error. It's just if you're trying to move really quickly where you're putting assembly together, if you're doing all your fastens at once, you won't have to redo this every time. You can just click check here. But if you are finished for like a certain amount of time and you want to just check everything out, then you just click this green check up here, and that'll finish, and it won't give you a new fasten. The only reason I want to do that is to kind of show you like a little bit of a 3D view of what's going on here. We've just connected our parts together, and again, they are glued in place. So this cannot move around at all. If you try to click and drag, because this base is fixed and this is fastened to our fixed base, nothing's moving. Okay, so you can go ahead and bring in your right panel and fasten that to the base. You should be able to do that on your own. So I'll do this kind of quickly. If you need to pause, you can pause. Alright, so hopefully you didn't have any problems with that. If you did, again, just pause the video, test some things out, see what went wrong. But you should have your base all put together. This is all fastened together, so nothing is moving at this point. Alright, so now we're ready to bring in the arm, and the arm is not going to be connected with a Fasten Mate connector because we want this arm to have motion. We want it to be able to move, rotating up and down. And then we also want the axis to be able to go kind of a little bit freely in and out of these two different holes of our base. So in order to do that, we're going to use this Cylindrical Mate connector, which actually is just a combination of two mate connectors you learned about last week, which were the Revolute and the Slider Mate connector. So if you combine these together, that is the Cylindrical Mate connector. So let's go ahead and bring in the arm. And then the only thing we need to realize and kind of check is that this needs to be facing up, right? We can't shoot any projectile out of like the back side of this. So if we have the right side of this arm, we need to make sure that it is connected to the right side of our base. And that's really the one important thing here. Other than that, you just have to pay attention to some of the details. So let's go ahead and choose that Cylindrical Mate connector. Then we'll select the first mate of the arm. Again, that is the right side, so we're going to be connecting it to the right side of our base. And then, depending on where we choose here, this will determine kind of it'll affect our limits. So I'm going to go ahead and choose, just to make it easy, I'm going to choose the most inside of our three planes. If you didn't get to this point in the last demo, you should have realized that you can choose multiple different planes. So you can always choose the back surface, the middle surface, or the top whenever you're adding a mate connector. We're going to choose the top for this one. So that will be our 0 position. Now, just because we chose that as kind of our starting position doesn't mean that we're not going to be able to move this along. Remember, the Cylindrical Mate connector allows for that side-to-side and the rotational movement. So we're going to have to set limits to make sure that it's not actually going through our plastic. But right now we do have a good start for what we're trying to get. So let's go ahead and go into our Cylindrical Mate connector and set some limits. So you can see we have 4 different limits we can set. We have a minimum side-to-side distance that we have a maximum side-to-side, we have a minimum angle, and then we have a maximum angle. So we'll start with the side-to-side minimum, and that minimum will be kind of the furthest point we want it to move on the inside. So if we see like right here, this very edge is at 0, that would be like the lowest we would want it to go. We don't want it to go any further this way, because if it goes any further this way than on the other side, it's going to start going into the plastic. So 0 is going to have to be our minimum here. Now, if you chose one of the different planes, like the middle or the far side, you would have to adjust your minimum to make sure that it is correct. But for me, where I chose the top surface, 0 is going to be my minimum. And then the furthest that I want it to go in would be the 5 millimeters. So my maximum would be 5. And so if we just press play really quick just to see where we're going, you can see that side to side it's going from 0 here, which is the furthest we want it to go in, to 5, which is the furthest that we would want it to go that other direction. So we've got our side to side limits perfect, 0 and 5. Again, that's because I chose this as my mate connector on the base. If you chose something different, then you might have to adjust that. But the last thing we'll have to do is to set our angle. And so right now we have our angle for our secondary axis nice and perfect, that this is at 0 degrees. Now this is not actually going to be our minimum because you can see that this is going into the plastic and that's not real. So we'll have to move this up until it's not touching the plastic, which is in reality at like 2.283 degrees. Now, if you do not have that, and this is what I saw in the last demo, some people were, having different secondary axis rotations. There's this button here, it says reorient your secondary axis. So basically, we can have this y-axis be straight up and down, we could have it sideways, we could have it down, or we could have it facing this direction. And so if for some reason your orientation doesn't have it the same as mine, where your 0 degrees is here and your 90 degrees would be like vertical, then you can just rotate this and make sure that that is the case. So 0 degrees should be flat here. If it's not, then reorient your secondary axis. But the minimum is not going to be 0 because we don't want it to be going into our plastic. The minimum is actually going to be, let's see how close we can get. About right there, 2.824. So our minimum angle, 2.824. And then the maximum angle is going to be all the way up to where we're contacting the rubber band bouncers, which would actually not quite be at 90 degrees, maybe be about at 88. So I'll set my maximum angle at 88. And then if we play that, we should see, boom, it stops there and it doesn't go into our base. So now that we have our cylindrical mate connector, we have our fasten mate connectors, we should have this realistic motion. And if you test it out yourself, you should see we got the side to side, which is exactly what we want. We want this to be able to rotate freely. And because it can go side to side, we also know that it can rotate down and up. And we know that we'll have rubber bands going across here, so that would stop this from being able to go any further. Okay, so hopefully you got this all down. Good luck on your homework, and I'm looking forward to all the projects that we're going to be able to do.